for the introduction, and thanks everyone for joining this talk on Native AMQP 1.0. So I'm David. I joined the RabbitMQ core team 5 years ago, and it's my 5th RabbitMQ summit, and I'm happy to be here. So this talk is about AMQP, and if you think back, it was 1 year ago in Berlin in exactly the same room, and Alvaro, who is also here today, say hello. He gave a keynote on AMQP 10 years after, and he was joking with AMQP 1.0 being the one true protocol, but nevertheless, we're happy to announce that RabbitMQ 4.0 supports AMQP 1.0 as a core protocol. Thank you. But stepping a bit back first, that we are all on the same page. So AMQP stands for the Advanced Message Queuing Protocol. And it was first developed around 2003 at JP Morgan. And the author, John O'Hara, was writing the motivation behind AMQP in an article in 2007. And there he was mentioning that use cases of the financial services industry included, for example, automated trading or buffering of market data events whose arrival rate was higher than the rate that could be processed by transactional databases. So they needed to have a buffer in the middle. So they needed to have a middleware with high performance as well and durability to avoid any message loss. And it should also have store and forward techniques or publish subscribe techniques. And the problem back then was that every major investment bank either built their own custom in-house message broker or they bought some expensive third-party solution. And the problem here is that messaging middleware is a hard problem to solve, especially if data is replicated to multiple nodes to achieve higher availability and to have safety of your messages. So the idea back then was to create a single standard for business messaging in order to avoid doing the same mistakes all over again and again at different organizations. And this is how the AMQP specification was born. And the requirements to the specification were that it's an open standard, that it's free of patents, that it's appealing for commercial implementations, and that it's a collective effort by many independent companies. And 20 years later, we can say that AMQP is not only used in the financial services industry, but in all industries and also used by the largest corporations around the world. And RabbitMQ is the most popular open source AMQP message broker. Now, there were different versions of the AMQP specification. And initially, RabbitMQ supported version 0.8. And since then, RabbitMQ has primarily supported AMQP 0.9.1. And if you look at the timeframes, it took almost 3 years to release the AMQP 1.0 specification. And during this time, there were many independent organizations. They all had their own interest. And basically, each organization wanted to make sure that their own in-house message broker either is compatible or can be made compatible with AMQP 1.0. And the protocol changed almost completely. So AMQP 1.0 is a completely different protocol to 0.9.1. Now, on a very high level, the difference is, and this is where AMQP 0.9.1 is special, that 0.9.1 defines the protocol between client and server, but it also defines the server model. So the 0.9.1 spec, if you read it, you will notice that it even defines different exchange types that must be present. And it defines the concept of queues and bindings. In AMQP 1.0, however, only the interaction between client and broker is defined. And it mentions abstractions such as target and source. So target is something where you send your messages to. In RabbitMQ, this would be an exchange, because RabbitMQ internally reuses the 0.9.1 model, which is the RabbitMQ model, for AMQP 1.0. And that's a good thing, because 0.9.1 model is very powerful and flexible. And then you consume in AMQP 1.0 your data from a source. So in RabbitMQ, the source will be a queue because you consume messages from a queue in RabbitMQ. And the 1.0 spec is even so generic that it doesn't even define that there must be a client or server. It only defines peers exchanging messages with each other. So if we compare the protocols a bit further, then we see that because no server model is defined, there are more brokers that can support AMQP 1.0, including RabbitMQ, but also Azure Service Bus and Azure Event Hubs as presented by Alvaro last year. There's Apache ActiveMQ, Apache Cupid, and IBM MQ, Red Hat AMQP, Red Hat AMQ, and some more brokers. On the other hand, we know that the ecosystem of the client libraries is better and larger with AMQP 0.9.1, and this is thanks to the popularity of RabbitMQ, because there are many community users who maintain their RabbitMQ libraries. Nevertheless, we have good clients for .NET and Java. By we, I don't mean us, RabbitMQ team necessarily, but the community. And AMQP 1.0 is also an official standard, so it's an ISO, IEC, and OASIS standard, while 0.9.1 is not an official standard. AMQP 1.0 has a modular architecture, and that's reflected even by the specification. So the specification is defined in different layers. So you have at the bottom the types layer, which defines the type system very well, which is also missing in AMQP 0.9.1. And then we have the transport layer on top, which defines the different frames. For example, the transfer frame, flow frame, disposition frame, and then open, begin, attach frames for starting connections, sessions, and links. And then we have the messaging layer on top, which defines the structure of the message with the different header sections and also different outcomes. For example, rejected, accepted, released, and modified. And then we have on top transaction and security layer. Now, the protocol itself in AMQP 0.9.1 is not really extensible. So RabbitMQ had to define its own custom protocol extensions. What is extensible, however, is the server model. That's what we are going to reuse in our AMQP 1.0 implementation. Because, as you know, you can write your own custom exchange types, and in RabbitMQ, you can even write your own queue types. And in AMQP 1.0, however, the spec is really designed for extensibility. So on the one hand, you have this layered architecture, and in theory, you can even replace the higher layer with another layer. For example, you could have a different messaging layer on the same transport layer. And many frames define special fields for extensibility and customization by a broker and clients. For example, the properties and the capabilities fields. And the best thing is that there are numerous extension specifications, and they have been developed way after the 1.0 spec got released in 2011. For example, RabbitMQ 4.0 makes use of HTTP over AMQP. This is something I will show later on. But there are many other extension specs, and we make use of some others as well already. For example, there's also the JMS mapping or claims-based security for renewal of OAuth 2 tokens. Now, the complexity of AMQP 1.0 is a bit higher, but on the other hand, you get more features, and that's also something I will show in the upcoming slides. And AMQP 1.0 also has a more sophisticated and fine granular flow control. We will also talk about this one. Now, one question you might ask is, given that AMQP 0.9.1 has been so successful, and it has made to RabbitMQ what it is today, like the most popular open source message broker, why do we invest into AMQP 1.0 at all? Like, why we are just not be happy and leave it as is? And the primary reason is its customer demand. So we have existing customers which ask for AMQP 1.0. Like, on the one hand, there are features. On the other hand, they would like to migrate from other AMQP 1.0 brokers to RabbitMQ. And then there's also about prospective customers. So if there's a new customer who would like to build a complete new messaging infrastructure for the entire enterprise, then it's better to just support the latest standard. So even if there's no technical benefit for this particular customer, they might be skeptical, why does RabbitMQ not support the latest AMQP 1.0 standard? Then we have more protocol features. Again, I'm going to talk about them. It's more extensible AMQP 1.0. AMQP 1.0 has improved performance in certain scenarios. And RabbitMQ is really a great multi-protocol message broker. In RabbitMQ, you can send messages with, for example, MQTT or STOMP or AMQP 0.9.1 or AMQP 1.0 or the stream protocol, and then consume the same message with a different protocol. And this is quite powerful, and we even document these internal translations which take place in the broker on our website. And last but not least, it's all about interoperability. Of course, you have your clients interoperable with RabbitMQ as an intermediary, but you also might want to bridge between different message brokers. And for example, there's a new feature in Azure Service Bus. So this slide comes from Alvaro. Thank you. And for example, what Azure Service Bus can do now is it exposes an AMQP connection string. What you then do is you just copy that string, paste it into the Shovel plugin, and off you go. You can forward messages back and forth between RabbitMQ, either running on-premise or in your cloud, and Azure Service Bus. And as a QR code, which you can also upvote for further ideas how to integrate RabbitMQ as a source for event stream in Azure. Now, how did AMQP 1.0 work in RabbitMQ 3.13? So this is the old version. There was a plugin, which you see in the green rectangle. And basically, this plugin took all the AMQP 1.0 traffic from the client. It then translated the messages to AMQP 0.9.1 and then proxied all traffic internally over the AMQP 0.9.1 protocol to RabbitMQ core. And this really limits the features which we can use in AMQP 1.0 to the subset of features which is available in the 0.9.1 protocol. So we would like to eliminate the AMQP 0.9.1 protocol here, but still use the powerful RabbitMQ model with exchanges, queues, and bindings. Also, it has slow performance due to the additional proxying, and it's resource heavy because for each connection you need to maintain additional state. So you need to have an additional AMQP 0.9.1 client in the AMQP 1.0 plugin. So in RabbitMQ 4.0, the client just connects to RabbitMQ via AMQP 1.0, and then it sends messages directly to an exchange and receives messages directly from a queue. This means primarily better feature support, but it's also faster and more resource light. So I did a few simple benchmarks in the upcoming slides and test the different queue types. So in these scenarios, I was using separate connections for publishing and consuming to have a fair comparison for AMQP 0.9.1 because that's recommended for 0.9.1. Each message is 12 bytes in size. Messages are durable, and we use confirms and acknowledgements. And then we see that with classic queues and AMQP 1.0 in RabbitMQ 4.0, this is on the left side, we get a throughput of around 100,000 messages per second. With AMQP 0.9.1, throughput is around 10% less. And now you see how the old plugin performed. So it was much worse, like 4 times less throughput. With quorum queues, the plugin didn't even sustain the benchmark, so the benchmark timed out and just didn't work. And again, with AMQP 1.0, we get a somewhat better performance compared to AMQP 0.9.1. With streams, the advantage is even a bit greater because streams internally in RabbitMQ encode messages in the AMQP 1.0 format, so you don't need additional translations when you already publish and consume via AMQP 1.0. In this benchmark, I connected 40,000 AMQP connections, each with 2 AMQP 1.0 sessions or AMQP 0.9.1 channels. And we see that the old plugin required more than twice of memory usage. So this is a 7 GB more memory usage on the RabbitMQ node. And AMQP 1.0 performs similar here compared to 0.9.1. Now, one of the great advantages of AMQP 1.0 is its flow control primitives. And it has link flow control and session flow control. And link flow control works as follows. So it's always the receiver which grants link credit to the sender. And this is because the receiver knows its current processing capacity at any point in time. And it can even dynamically increase, decrease the link credit it grants, or grant different link credit to different senders. Now, when I say receiver and sender, it could be either side. So if the client is the receiver, then of course RabbitMQ is the sender. If the client is the sender, then RabbitMQ is the receiver. So the upcoming slides, let's assume the client is the receiver, so it's the consumer, just to keep things simple. So in its simplest form, the client grants a single link credit to RabbitMQ, the sender, and then RabbitMQ is allowed to send a single message. So that's a synchronous GET, basically. However, this is slow in performance, so typically clients grant multiple link credit at once. For example, let's say it grants 6 credits initially, and then whenever the remaining link credit at the client falls below a threshold, let's say 3, so half of 6, it renews, it regrants 6 link credit. And this then results, of course, in better performance. So it's asynchronous pattern. So from what I can tell, the link flow control in AMQP 1.0 is based on a paper from 1995 called Credit-Based Flow Control for ATM Networks, written by Robert Morris. And I copied this picture from the paper because it illustrates nicely how link flow control works. So we have the sender, and the sender has its own transmission count, it's called, and the receiver, which has its own forward count, so they always get incremented when a message is sent or processed at the receiver. So these are called delivery count in the AMQP spec. And then we have the receiver, which knows its allocated buffer, and again, this one can increase or decrease dynamically. Usually it stays the same. And then the receiver periodically sends these credit commands, which are sent in flow frames in AMQP 1.0, to the sender. And it includes 2 information, or at least 2 information, namely the currently allocated buffer and its forward count. And based on this information, since the sender knows its own transmission count, it can accurately determine how many more messages it's allowed to send to the receiver without overflowing the receiver. And there might even be messages in flight currently, or messages might be already received by the receiver but haven't been processed yet. But still, with this simple protocol, we can make sure that the sender never overflows the receiver. So it's really very fine-grained. And if you think about it, this is a really huge advantage of AMQP 1.0 in RabbitMQ, because now it means that the consumer can dynamically, which means at any point in time, adjust how many messages it wants to receive from a specific queue in RabbitMQ. It can also even prioritize which queue or queues out of multiple queues on the same connection and session it wants to receive messages from. And this is really much more fine-grained compared to AMQP 0.9.1, where you would just do a basic consume with a given prefetch, and then you constantly receive your messages, where you acknowledge your messages and then you receive more, but you don't have this fine-grained control with AMQP 0.9.1. So there are many more benefits. So if you look, for example, at how flow control works internally in AMQP 0.9.1 in RabbitMQ, then this is a picture that I copied from a 2019 blog post. And basically what it shows is that if a single target queue on a given connection is overloaded, so in this case it's a quorum queue, eventually the Erlang reader process, which is responsible for reading AMQP frames from the socket, will stop reading from the socket and therefore intentionally blocking the entire TCP connection and causing TCP back pressure to the client in order to protect RabbitMQ. And this does not only protect the single slow target queue, but it blocks the entire AMQP 0.9.1 connection. And I wanted to know, so I was writing, this blog post about link flow control, and was writing, AMQP 1.0 should perform better. So I wanted to know whether it's really true. So I wrote a simple benchmark. On the left-hand side, you see a single Go program. It has 4 Go routines. Each Go routine is a publisher. And it sets up two AMQP connections, one AMQP connection for 091 and one AMQP connection for 1.0. And each Go routine publishes as fast as it can to its own dedicated target queue. And on each protocol, we have a dedicated classic queue and a dedicated quorum queue. And as you know, quorum queues need to fsync the data to disk in order to confirm them back to the publisher. And they also need to replicate data to different nodes and need to get a majority of responses, and then the message gets confirmed back to the publisher. So quorum queues generally accept messages, therefore slower, but of course in turn you get a higher data safety. So if you run this benchmark for 10 seconds, then we see something very interesting. Namely, in red, that's AMQP 091, we see that we get roughly the same number of messages ending up in either target queue, so either in the classic queue or in the quorum queue. However, we know the classic queues can accept messages faster. But because the whole TCP connection gets blocked and unblocked many times per second, so my benchmark was around 80 times, the client is not only throttled sending to the target quorum queue, but also it's throttled to sending to the target classic queue. And in AMQP 1.0, however, you see here an additional digit, so you can send more than 1 million messages to the target classic queue. And this is really thanks to link flow control in AMQP 1.0. And that's because the target quorum queue, if it accepts messages more slowly, then it will simply grant link credits less frequently to the publisher. On the other hand, the target classic queue, which accepts messages faster, grants link credit more frequently. But at no point is the entire TCP connection blocked on purpose by RabbitMQ. Now, this does not only apply to publishing, it also applies to consuming. So now we have another benchmark, very similar to the one I just showed. But in this case, we pre-populate each classic queue with 1 million messages, and then we consume from the classic queue as quickly as possible. We still publish on the same connection to the target quorum queue as quickly as possible. So it's publishing and consuming on the same connection. And again, here we see that with AMQP 091, we can only consume around 9,000 messages per second in this scenario, because the entire connection is again blocked. And as you know, with your AMQP 091 client, it needs to acknowledge the messages in order to get dispatched more messages from RabbitMQ. In AMQP 1.0, we get around 663,000 messages. So in this benchmark, it's 70 times more. And this is because, well, in AMQP 1.0, the consumer also needs to periodically grant more link credit to the to RabbitMQ in order to receive more messages. However, again, at no point is the entire AMQP connection being blocked on purpose by RabbitMQ. And again, this shows the power of link flow control, because it's very fine granular and it's there to protect individual queues in RabbitMQ. And basically, it's a quite big performance difference, and I don't claim that you will see them if you use AMQP 1.0. This was just a scenario that I was setting up in order to, provoke and to see the differences in action. But I do claim that if you have if you publish at full throughput to more than one target queue, or also consume at the same time, then you will see a better performance. And it also means that you can safely use a single connection for AMQP 1.0. So this is actually a known problem in RabbitMQ, and that's why our documentation recommends, hey, use separate connections for publishing and consuming. And then, we have dozens of client libraries which comply with this best practice and use the separate connections for publishing and consuming. But to me, it's more like limitation, a workaround, not really a best practice. So the best practice is done by AMQP 1.0 in this case. Okay, there are more benefits of link flow control. In AMQP 1.0, we can now pause consumers. We can resume them later on. It's not possible in AMQP 0.1. How does it work? The consumer simply grants a link credit of 0. That's it. Another advantage is that with AMQP 1.0, the sender, so RabbitMQ, can inform the consumer about the number of messages available in the source queues, because there's a dedicated available field in every flow frame that's sent from RabbitMQ to the client. This is not yet implemented, but in theory, the sender can even notify the receiver once new messages have become available, and this is quite powerful because then the client doesn't need to poll or necessarily wait for messages becoming available. There's a properties field as well, which is designed for extensibility for future use cases. So broker clients can use it for whatever they want. Then we have session flow control. It operates at a higher level. So link flow control was there to protect individual queues in RabbitMQ, as we have seen. It's also there to protect individual consumers in the client application. Session flow control, on the other hand, protects RabbitMQ as a whole and the entire client application. So it's a different use case. And we use currently session flow control in the event of a cluster-wide memory or disk alarm. So in that case, RabbitMQ will block AMQP 1.0 clients from publishing messages via session flow control. And clients can nevertheless use any other frames, so they can continue consuming on the same connection. And again, this is not possible with AMQP 0.1, because in AMQP 0.1, it's implemented by blocking the entire TCP connection, which again means that you need separate connections for publishing and consuming. We also wrote our own RabbitMQ AMQP 1.0 clients for Java, .NET, Erlang, and Go. And they are just thin wrappers around existing open source AMQP 1.0 client libraries. For example, they integrate the RabbitMQ model, which means that applications can manage the RabbitMQ model through AMQP 1.0. So applications can still create, declare, delete the queues, bindings, exchanges, just like AMQP 0.1 clients. And this is so that applications, and that's a term John O'Hara was using in his article in the original motivation of AMQP, can continue to maintain an intimate relationship with the middleware because they know the server model. And optionally, the apps can even bypass our wrapper and call directly in the underlying clients to get the most features out of AMQP 1.0. These client libs are just optional. You can use any other AMQP 1.0 client to communicate with RabbitMQ. The only advantage they offer is they have a bit of RabbitMQ specific logic built in. For example, the Java client also offers a feature to publish locally and consume locally to queues. So if you look at how declaring objects works, then you see that we use the HTTP over AMQP extension specification. So this is a Wireshark capture. And on the left-hand side, you see a request. On the right-hand side, you see a reply. And in the request, well, first of all, you see that both use the transfer frame. So we use AMQP 1.0, but put HTTP semantics into the message headers. So that's what's meant by HTTP over AMQP. And this way, internally in the broker, we can, for example, access the HTTP API over AMQP. And therefore, we have much more features available compared to what's predefined in the 0.1 protocol. So in this case, the client does a put on an HTTP path, queues my quorum queue in order to create a quorum queue. It also includes a message ID, and the server will reply with 2 or 1 created. It will also copy the message ID into the correlation ID. And now, because we can include more information in the response, RabbitMQ also returns queue topology, which means, for example, where the current leader is located, and also the number where the replicas are hosted of a quorum queue. Now the client in turn can use that information for queue locality. So the client in AMQP 1.0, if you use the Java client, can then connect directly to the RabbitMQ node, which hosts the quorum queue leader, because all publishers need to go to the leader first anyway. It makes sense that the publisher directly connects to the node hosting the leader. And likewise, if you consume from a quorum queue, you can directly connect either to either of the three nodes. You can also connect and consume locally from a follower. So in AMQP 0.9.1, however, you will probably connect to any node because you probably don't have topology information. So it might happen that you connect to node 3, and then this means it's just an additional arrow here, but what it really means is that a lot of message payload internally needs to be sent from node 3 to node 1. And this can be large message payloads, can be many messages, and this of course means lower throughput, higher latency, and even higher cost. In certain cloud providers, you need to pay for messages if they transfer, across availability zones within the RabbitMQ cluster. Another small advantage of AMQP 1.0 is sender settle mode mixed. This simply means that the sender can request to receive a publisher confirmation from RabbitMQ on a per message basis. So it will save a few disposition frames coming back from a RabbitMQ. I don't think this gives you any notable performance benefits, but it's a nice feature. Yet another feature of AMQP 1.0 is the modified outcome. So we were publishing a blog post last Friday about this feature. And basically in AMQP 1.0, you have the accepted, rejected, and released outcomes, which are all supported by AMQP 0.9.1. But you also have the modified outcome. And this means that a consumer in RabbitMQ, before it requeues a message in RabbitMQ, or before it deadletters a message, it can modify message annotations, so some headers of the message. And this is really powerful because it enables now consumers to include a custom reason why the message was requeued or why the message was deadlettered. And you can even track a history of requeue and deadletter events. So you can even, thereafter analyze, for example, if you have a header requeued by a client, then you can even analyze what consumer was causing the requeue and for what reason. And you can even, and this is showed in this picture here, you can even decide in the consumer where your messages will be deadlettered to by setting a specific message annotation. And this works by sending your messages to a headers exchange. So this is your X deadletter exchange. It would be a headers exchange. And then in this case, because the message annotation is XOP deadletter category business logic, it would match with this header, with this binding, and then end up in this business logic failures deadletter queue. So this now enables you to have different teams or different apps process deadletter messages differently and take different action. You could even have different queues for retry mechanisms. So you could have a queue which will retry in 5 seconds and another queue where messages should be retried in half an hour, or another queue where messages are never retried. So it's quite a cool feature of AMQP 1.0. Yet another advantage of AMQP 1.0 is the immutability of the bare message. So in the messaging layer, this message structure is defined. So this is the spec. This is a copy-paste from the spec. And you have the bare message, and this consists of the properties, application properties, and application data sections. So this is where your payload goes into. And what the spec mandates is that this whole bare message is immutable. And this in turn means that clients can set, for example, a hash or an HMAC or a signature, digital signature, into the footer. And then clients can validate end-to-end that the integrity not only of the payload remained intact, but also over those headers here. And that's not possible with 0.9.1, because in 0.9.1 you can include a hash in your header, but only over the payload, because in 0.9.1 the broker can and will modify headers in the message. Right. So To wrap up, AMQP 1.0 has become a core protocol in RabbitMQ 4.0. It's enabled by default. There's no plugin required. It's a better defined, more feature-rich, and in some scenarios, more performant protocol than AMQP 0.1. And it's also more interoperable with other message brokers. And it's designed to be extensible and therefore allowing us to add new features to RabbitMQ in the future. So what's next? This is something I can already promise. So in RabbitMQ 4.1, we will get a subset of the AMQP filter expressions extension. So again, this is a different extension specification. And this allows to consumers to filter messages when they receive from a stream in RabbitMQ. And this now allows to have a stream, so you have your total message order, but you can have multiple concurrent clients, each consuming from the same stream, while each consumer only gets those messages dispatched it is interested in. And they do so, if you go back, then they can filter based on fields in the property section or based on fields in the application property section. And the clients can even do prefix and suffix matching on strings. So it's quite a cool feature. The extension, again, this is only a subset which we implemented. The extension also allows filtering on those headers here. Maybe we do it in the future, maybe not, depending on feedback. And the extension even has a more complex SQL filtering syntax as well, which is probably more interesting for JMS use cases. We also try to make AMQP 1.0 a bit more developer-friendly by continuing to invest into client libraries and also by writing AMQP 1.0 tutorials. And then I mentioned a few features, where AMQP 1.0 has more features compared to 0.9.1. So partly they're implemented, partly there are many features which aren't implemented yet, which we could implement in the future. But currently, as it stands, and we had to ship something, there are also still features which are only available in 0.9.1. And this is not due to limitations of the 1.0 protocol, it's just because we haven't implemented them yet. And my hope is also that we close this gap first, because otherwise existing client applications have issues upgrading to AMQP 1.0. So those features include, for example, OAuth2 token renewal, channel interceptors, direct reply to feature, and some observability and metric stuff. Last but not least, we would like to mention that we, of course, continue to fully support AMQP 0.9.1. So no need, to get worried that you don't get support for 0.9.1 anymore. It's the opposite. We still support and even invest in 0.9.1. We I think release the .NET 0.9.1 library soon, a new version. So we still do a lot of work in that area. Yeah, also thank you a lot to the team who contributed to AMQP 1.0, specifically Carl. So years back already, he added AMQP 1.0 features to quorum queues. And basically, years back already, he created a clean queue-type API, it's called, within RabbitMQ, which decouples the protocol. Back then, it was only AMQP 0.9.1 from the queue implementation. Back then, it was only the classic queue. So nowadays, we can have more protocols using that same nice, simple API and more queue types. He also implemented message containers in RabbitMQ 3.13, so it didn't, have much. It was not a very user-facing feature, but it was a lot of hard work because it internally changes the structure of how messages are stored in RabbitMQ. And this whole work was a prerequisite to even get started with native AMQP 1.0. Then also thanks to Arnaud, who writes excellent high-quality Java libraries, including the Streams library and also the AMQP 1.0 Java library. To Gabriele, who ports those Java libraries to various other languages. He did it for Streams and now also for AMQP 1.0. And also thanks to Luke for contributing to the .NET AMQP 1.0 client. Yeah, that's it.
Okay, yes, thank you, David. Do we have a question from anyone? Questions on? Yes, I see a question in the back.
I have great talk, thanks. I have one question about filtering. So there is already some filtering in the stream client, this Bloom filter based. How efficient or how does it compare with the AMQP 1.0 filtering?
Yeah, excellent
Isn't there
question.
an overhead of that one?
Yeah, good question, thank you. So first of all, to step a bit back further, the different mechanism how you can filter messages in RabbitMQ. Like normally, as you know, you would use a binding to filter messages so that your message ends up actually in the queue only if you're interested in consuming that message as well. So filtering normally happens on the binding level. Last year, we were releasing filtering for streams via the streams protocol and actually also via AMQP 0.1 and AMQP 1.0. And this filtering works on a different level. So it uses a Bloom filter. And in each chunk, so chunk is the unit that gets sent over the network to a stream client. Either the message matches this filter or not. So either get all the messages in the chunk or you don't. And you also have false positives. So it's the Bloom filter is slightly more efficient, I would say. But you can combine both. So you can combine the filter expressions in RabbitMQ 4.1 with the Bloom filter, which is already present in streams. The difference is that the filter expression feature, the new one, is more fine granular. It shouldn't cause too much overhead because each message is already, if the message is delivered from a stream to an AMQP 1.0 client, each message is already taken into memory and somewhat passed. The header sections are already passed, so it simply runs a matching on top. Now, of course, if you have, I don't know, if you create complicated filters, 10 filters, then you will notice probably a slight overhead, but I wouldn't expect you notice a bad overhead. But yeah, it's more fine granular, and the difference is also that you can filter on multiple fields. So you can now filter on multiple fields, and you can also do prefix and suffix matching, so it's more fine granular and more powerful, I would say.
Great. I think we have one more question.
Yeah. Hey, David. My question is regarding the clients, AMQP 1.0 clients. Microsoft has clients for Service Bus and Event Hubs. Do those work with the new RabbitMQ? And do the new RabbitMQ 1.0 clients work on the other side? Because at the end, the goal of AMQP is interoperability. And I will guess the dream is that we can just swap the connection constructor at some point and either migrate from Rabbit to Service or from Service to Rabbit. So have you done any tests in that regard?
Also, excellent question, thank you. So Microsoft, they developed a really great, or multiple great, .NET AMQP 1.0 clients. And one is called AMQP.NET Lite. And they have different layers of clients. So they have this .NET Lite AMQP 1.0 client library. And then they built their own Azure-specific client wrappers around that core library. And actually, our RabbitMQ client, which is also just a wrapper, does the same approach. It also uses the .NET, actually the .NET developed by Microsoft, the .NET AMQP Lite client, and just has a thin wrapper with RabbitMQ specific logic. Now, what doesn't make sense is that you use our new RabbitMQ specific client with Azure. It also doesn't make sense that someone uses the Azure client, the Azure wrapper with RabbitMQ. But what makes sense is that you can use the same lower level client, so the .NET Lite client, with either Azure or RabbitMQ. So there we have interoperability. But the wrappers, which are just a thin layer around, they are not interoperable. They are meant to be specific to one broker implementation.
Yeah, one more question.
Yeah, we're running RabbitMQ on-prem, still version 3.13 with the old AMPQ. Well, if we use the new one and with the new RabbitMQ 4.0, do we need more resources? Because I presume the filtering mechanics use more CPU and more memory.
So it only uses more CPU if you use the filter expression actually. So it's you just opt in. But again, I think it's similar to the question from Peter. So there's no really noticeable overhead. I wouldn't expect that you have like more CPU or memory usage due to the filtering extension I just showed. So are you using AMQP 0.91 or 1.0 in your current setup? Like the which AMQP specification? 0.91 to use right now, or?
I really don't know.
Okay, but either way, there shouldn't be any additional overhead. I think it's even the opposite. So if you have AMQP 1.0 right now in Future 13 and you upgrade, you get much better performance, as I was showing in the benchmarks. Yeah.
All right, thank you. Let's thank David again, and then we'll head to a coffee break.